Today I am going to cover exponential and Poisson distributions. Exponential distribution is a continuous probability distribution. Poisson distribution is a discrete probability distribution. X equal to k probability of x equal to k here in continuous distribution is 0, but here probability of x equal to a specific value, specific integer value, is not 0. Exponential distribution talks about time, inter-arrival time, between two events. Poisson distribution talks about the number of events in this interval, in a specific interval. As the average in Poisson distribution gets larger, the shape of the Poisson distribution from something like this goes toward something like this. As the number of events in a specific time interval increases, the curve gets closer to normal distribution. But don't forget, normal distribution is continuous probability distribution, while Poisson is discrete. Let's provide you with some examples of exponential and Poisson probability distribution. Exponential random variables could be time between arrivals of two vehicles to a toll booth, distance between two defects in a highway, time required to complete a questionnaire, time it takes to complete a task. In waiting line applications, the exponential distribution is often used for inter-arrival time of orders. That is a very legitimate assumption, but when we assume it as processing time, it is just to make the mathematical model simpler. For processing time, our assumption that the time follows exponential distribution is not that much strong, but it is very strong for inter-arrival. In exponential distribution, one event is independent of all other events. We may have several cars coming quickly after each other, and we may have the next one also come quickly after. Or we may have two cars with a long time between interval of them, then we may have the second one with the long interval time, then we may have a third one. If we have three interval time which are all long, there is no guarantee that the fourth one is not long. In general, exponential distribution looks like this. Probability of having small numbers is higher than probability of having large numbers. Examples of Poisson probability distribution could be number of defects in, say, 10 linear feet of something. Number of vehicles arriving at the toll booth in a specific time interval. Poisson distribution tells us how many events happened within a specific time interval. For example, 10 minutes. Exponential distribution talks about the time between arrival of two consecutive flow units, and therefore there are some relationships between these two distributions. You don't need to be worried about formula. Just I want to tell you a couple of things. Probability of x less than or equal to k. Suppose this is k, specific value. This is exponential probability distribution. Probability of x less than or equal to a specific value is this area. It has a formula, we can use it, but the good news is computing this part is easier. So if I have k, probability of x greater than or equal to k is easy, and that is e to the power of negative k divided by mu. Mu is the average of the distribution, and in Excel language it is exponential of negative k divided by mu. That is this probability. As soon as I find this probability, I can subtract it from 1, and then I have this probability. As easy as that. However, if I'm interested in computing this probability, I can use Excel formula of exponential distribution. The only thing that makes me not use this Excel function frequently is because of this. You cannot enter average over there, because average is in terms of time. For example, 10 seconds. You cannot enter 10 seconds as average. You should enter rate as an average, and that is 1 divided by 10 seconds. So if every 10 seconds on average 1 flow units arrive, that means 1/10 of a flow unit arrives in 1 second. We will go through more practices. Let's look at this problem. This is exponential probability distribution, and average is 3 minutes. So mu here, or lambda, is equal to 3 minutes. The problem asks, what is the probability that the time between 2 consecutive arrivals is 2 minutes? So the time between arrivals of car at a gas station follows exponential distribution with average of 3 minutes. What is the probability that the time between 2 successive arrivals, 2 minutes or less? So 2 minutes is here, and the problem is asking 2 minutes or less, asking for this probability. I can do 2 things. Exponential distribution. And this exponential distribution, it says the probability of being less than 2. What is the average? Is 1/3. I said I cannot enter 3 minutes, but it should be in terms of rate, 1/3, and then cumulative, because this is continuous probability distribution, and if we put it 0, that it will not give us a probability, it will just give us the height of the curve, and we can use it to draw a neat curve of exponential distribution. Therefore, I put 1, and that probability is 48%, 48.6. Alternatively, I can compute this side and then subtract it from 1, and then that would be equal to what I have computed. Equal to x. X means e to the power of something. And we said negative k. Our k here was 2 minutes divided by our average was 3 minutes. That's it. Enter. Now, if I go here and subtract this one from 1, then I will get that one. Therefore, this was the blue that I got, and this was the red. But if I subtract red from 1, I again get exactly the same blue. Okay? So there is a company, they have promised to deliver the service in less than 5 seconds. And if it exceeds 5 seconds, then the transaction would be free, and that's a $11 transaction. The average for this exponential distribution is 1 second. And we want to find the probability that it takes more than 5 seconds. We can compute this in 2 ways. I can easily compute that right-hand side as equal to exp negative, the x value that I'm looking for is 5, and the average is 1. So that is the probability to the right-hand side, and I get it. Alternatively, I can compute the probability to the left equal to exponential distribution. That is this one. And then x is 5. Average is 1 divided by 1, which is the same as 1, since average is 1 second. And then we need to find the cumulative. So I enter 1. Therefore, I get the probability to the left. If I subtract it from 1, then I get the probability to the right. Is this one equal to this one? Oops. That is a little bit difference, perhaps. Yeah, here, this is 7 here in the last part. Here is 8, but the rest of the numbers are similar. So that is the probability. And how many people visiting this site? 150,000 multiplied by this, and that is 1010. And we don't get 1099 for these numbers, and therefore that is something like this. Something like this, that is a round of errors. Now suppose we wanna improve the service by 50%. So instead of 5, we have said if you cannot be served in 2.5 seconds, then the service is free, and we are looking for this probability. Again, 2 choices, equal to exp negative 2.5, which is x, divided by 1, which is the average. We get this percentage, or exponential distribution. X is 2.5, average is 1 divided by 1, and here we need to enter 1 for the probability. Then we subtract this one from 1, and that is the probability. If you multiply it by 150,000 people who visit this site, it's much larger here. And if we multiply this by 1099, which is cost of each transaction, that would be this much. Copy, paste the special. And then let's go back to the original situation. This one was 5 and 1 and 1. So that is this many people. And if you multiply by 1099, that is this one. Now, if you divide this one by this one, our cost has got 12 times, more than 12 times, while we were able to improve the service by 50% from 5 seconds to 2.5. We can say we doubled the service level. The quality of the service level got doubled from 5 seconds to 2.5. Or we can say we improved it by 50%, but that cost us a lot, from about 11,000 to 135,000, about 12 times. We got the promised time by half as the improvement in quality, but our cost got 12 times, about 1100% increase. Both the waiting time and the service time is exponential. With average of 15 minutes. The pharmacy has promised to fill all prescriptions in 30 minutes. The percentage of customers cannot be served, compute them. So this is 30 minutes. What percentage cannot be served in that time? Equal to x negative 30 minutes, that is my x, divided by average, which is 15 minutes, and that probability is 13%. Alternatively, I could have said equal to exponential distribution. X is 30, average is but 1 over 15. We said when we use exponential distribution, don't forget that you cannot enter the average of exponential distribution. You need to divide 1 by average value, equal to 1 minus this value. It is the same. Here is the solution, and the solution, and the solution. 90% of customers are served in less than what time interval? This is a good question if you can answer. The same distribution, 90% of customers are served in less than what time interval? 1, right click, go up, leave it, series, in a column, go to 100, correct? Now I have from 1 to 100, right? And then here I type equal to x negative 1, which is my x, divided by average, which was 15. That is probability to the right. Probability to the right. 90% of customers are served in less than what time interval? So if 90% of customers form time to the left, then time probability to the right is 10. And this is probability to the right. Now it is 90%. I'll copy it down. 80%, 20%. I'll go down, 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 down. 10%, 10%, around here. Something between 34 or 35 minutes. 90% of customers are served between 34 to 35 minutes. I could have done this to 1, 10, then I could have come here, equal to 1, enter, equal to, so 1 plus this one and F4, and copy down. So I went down to 101. I could come here and type equal to this one, enter. I could have marked this data, what if analysis, data table. I have my data in a column. And what is my data? It is this one. Okay, now it fills it, okay? 12%, 6%. So it is between 31 and, so I type here 31, and then I type here 1. 10%, 9%. So I go and type here 34, and I type here 0.1. So it's 10%, 10%. So it is between 34.5, and I type here 0.01. 10%, 10%. So it's 34.53 or 34.54. You see, this is 2 procedures. Let's go for the third procedure. Data, solver. Solver, please look at this. By changing this and set the value to 10%, 0.1, and please solve. Okay, 34.53. So I showed you 3 ways to solve that problem. Okay, these are not easy examples. If you can solve this problem, you can say you are perfect in exponential distribution as long as a business school student is concerned. The number of days that elapse between the beginning of the calendar year and the moment a high-risk driver is involved in an accident is exponentially distributed. An insurance company expects 30% of high-risk drivers will be involved in an accident during the first 50 days of a calendar year. The problem is stating this. Accident for high-risk people follows exponential distribution. Average, we don't know. But we know that out of these people, if this is 50 days, 30% of them will have an accident. So this probability, if this is 50, this probability. If that probability is 30%, what is this probability? This is 70%. Therefore, X negative 50 divided by mu, which we don't know what it is, should be equal to, using the previous procedure, using any of those ways you can compute it. I just use solver. Suppose this is mu, and suppose it is 10. Therefore, here probability to the right is equal to exponential negative 50, which is our x, divided by mu. Correct? Enter. That is probability to the right, and we want this to be equal to 70%. So I'll go to solver, because to the left is 30, to the right should be 70%. Go to B2, set its value to 0.7 by changing this one. Solve. Okay. So the average for this distribution is 140 something. Let's go to the next part of the question. Calculate the probability high-risk driver to be involved in accident in the first 80 days. Now the problem is quite simple. Equal to x, which gives me the probability to the right, negative. My value is 80. Average is this one. That is probability to the right, probability to the left is 1 minus this, which is 0.4348. Look, if you can solve these problems, that means you are really good. These problems that I marked them not easy, If you can solve them, that means you really are good. Lifetime a printer which costs $200. Lifetime is exponentially distributed, and average is 2 years. We have accepted that it fails in the first year, we pay $200, and if it fails in the second year, we pay $100. Therefore, what is the probability to fail in 1 or less year and 2 and less year? But we need to subtract this one from this one. I type here 1 and type here 2 equal to 1 minus, because I'm going to find the probability to the left. The value is negative 1 year divided by average, which was 2 years. That is the probability. And I can bring this 1 instead of 1. I can type this, enter. That is the probability of fail in less than 1 year, less than or equal to 1 year. This probability of fail in less than or equal to 2 years. So the 2 year is this one minus this one. That is the probability to fail in the first year, and this is the probability to fail in the second year. 200 is here, and 100 is here, and sum product is here. These two, comma, these two, and that is 102, and it has asked for 100 printers. 100 printers equal to this multiplied by 100, and there's 10,255 or 10,256. If you can solve these problems, if you can follow these problems, that means you are good.